Okay. So in continuation, whatever we have done in fossil laws of motion, we have law of conservation of momentum, right? So as we know that momentum is the product of mass and velocity, right? Law of conservation of momentum, which is a result of Newton's third law of motion. And according to this law, the total momentum of a system of objects remain conserved before and after their interaction, or you can say collision, provided that there is no external unbalanced force acting on them, right? So please write down. Okay. So what it says, that the total momentum of a system of objects remains conserved before and after the collision, right? Provided that there is no external unbalanced forces acting on them, right? So means in a system, right? In the system of objects, the total momentum before and after the collision will always remain same, right? Okay. This is called law of conservation of momentum, right? Now, what does it mean? It means that suppose we have two balls, right? Yeah. So suppose ma is the mass of one object, right? mb is the mass of the second object. ma is moving with a velocity of ua. mb is moving with the velocity, initial velocity ub, right? Okay. So this is figure A before collision. They are moving with two different velocities, right? UA and UB, and their masses are MB and MA, right? This is figure A, shown by figure A before collision, right? Now, in figure B, collision occurs, right? This is object A, this is object B, right? So there are certain forces, means a force applied by ball A or the object A to B, and similarly, a force which is applied by object B to A, right? In the opposite directions, right? So after collision happen, their velocity get changed, right? Mass remains same, mass cannot be changed, right? And now this time ma is moving with the velocity va and mb is moving with the velocity vb, right? And this is the figure after collision. Okay. Oh, sorry, this is C, figure C, right? So there are three figures you can see here. Figure A shows the two objects moving with two different velocity in a direction. Now figure B shows the collision. There is a collision occurred because their velocity is different, initial velocities, right? And after collision, they start moving in the same direction with different velocities, VA and VB, right? So now, according to this law, the conservation of momentum before and after collision, total momentum before and after collision will remain same, right? So very first, we will find out the total initial momentum. What will be the total initial momentum? Means before collision, it is ma moving with velocity ua plus mb moving with velocity ub. This is total initial momentum. After collision, total final momentum will be ma moving with velocity, final velocity va plus mb moving with final velocity v, right? And according to this law, total initial momentum is always equal to total final momentum. Total initial momentum is equal to total final momentum. And this is law of conservation of momentum. Is that clear? So before and after collision, momentum will remain same. Total momentum. We are talking about the total momentum. So MA UA plus MB UB, this is equal to MA VA plus MB VB. Okay, and this is called conservation of momentum. Is that clear? What is conservation of momentum? It says that total momentum before and after collision will remain same, right? So total initial momentum will be the momentum, addition of momentum of individual objects, getting, moving with some initial velocity. Yes or no, Alisha? Because momentum is what? Momentum is the product of mass and velocity, right? So for object A, momentum will be MAUA. For object B, momentum will be MBUB. And therefore, the total momentum will be the addition of these two. Now, total final momentum after the collision is again the momentum of the two objects, right? Means MA moving with velocity, final velocity VA, and MB moving with the final velocity VB, right? So this is the total final momentum. And according to the law of conservation of momentum, this is same. Means total initial momentum is always equal to the total final momentum. Okay, is that clear? So we are not going in detail into this, right? Okay. Like what are the application and how to use these formula within the numericals, right? So we are not doing that because it is not in your syllabus. So let's start doing the questions. Have you noted? Yes or no? So in this question number 1, a force of 6 Newton gives a mass m1, an acceleration of 18 meter per second square, and a mass m2, an acceleration of 24 meter per second square, right? So there are two masses, and the same force 6 Newton gives the acceleration of 18 meter per second square to mass m1 and 24 meter per second square acceleration to mass m2. Now, what will be the acceleration if both masses are tied together? The same force, how much this same force will produce the acceleration if both the masses are tied together? So this is the question. So very first, write down what is given to you, right? So force is given. What is the force given here? Alisha, force is 6 Newton. Yes or no? 6 Newton is the force, right? Now, acceleration of mass 1. Right? M1. Suppose it is A1. This is 18 meter per second square. This is given. And acceleration of mass M2. Suppose this is A2 and this is 24 meter per second square. Right? Since force is same, can we find masses? Can we find M1 and M2? Are you getting that? And we keep a video on. Right? Can we find M1 and M2? Yes or no? Because acceleration are given for both of them and force is same. Right? So by the Newton's second law, F is equal to M into A, right? Okay. If we consider the mass 1, F is equal to M1 into A. So we can find M1 is equal to F upon A. A is A1 here, right? Okay. Force is 6 Newton. A1 is 18. 18 meter per second square. That is 3, means 1 by 3 kg, right? So in this way, we have found out that mass of first object, M1, is 1 by 3 kg. Similarly, for the second object, second mass, so Newton's second law will be F is equal to M2 into A2 because force will remain same, F is same. So it's similarly, we can find M2, which is F upon A2, right? F upon A2. F is same, 6 Newton, and A2 is this time is 24 meter per second square, right? So this is 1 by 4 kg. Getting it? 1 by 3 kg and 1 by 4 kg. Now, in the question, they're asking like, what will be the acceleration if both the masses were tied together, right? That means what will be the total mass if both masses are tied together? Total mass will be m1 plus m2. Getting that? Okay. Means 1 by 3 plus 1 by 4 kg. Okay. That is 12. 4 plus 3. 7 by 12 kg. Right. This will be the mass, total mass, if both the mass are tied together. 7 by 12 kg. Right. So force will remain same. Mass, total mass of the, when both are tied together, we have find it out 7 by 12 kg. So we can easily find the acceleration produced into it. Right. So write down. So acceleration produced in combined mass, right, will be, now again this time F is equal to M into A, right? Okay, A is equal to F upon M. Now this time M is M1 plus M2 because we have tied the masses, right? F upon M1 plus M2. So F is same, force is same, 6 Newton. M1 plus M2 will be 7 by 12 kg. Getting it? 7 by 12 kg. Now we can solve this. Okay, take this 12 here and multiply 6 into 12 upon 7, right? So what it will become? Do it. 72 by 7, right? Divide it. It is around 10.28 meter per second square. Unit of acceleration is meter per second square. So the same force will produce an acceleration of 10.28 meter per second square if both the masses are tied together. Is that clear? Alisha, are you getting it? If a force of 1000 Newton is applied over a vehicle of 500 kg, then in how much time the velocity of the vehicle will increase from 2 meter per second to 10 meter per second? Also find the impulse, right? So what is happening in this case? That there is a vehicle of mass 500 kilogram, right? And a force of 1000 Newton is applied over it, right? So since external force is applied, its velocity will change, yes or no? And its velocity is changing from 2 meter per second to 10 meter per second. Now what you have to tell? You have to tell that in how much time this change will occur, right? Means 2 meter per second to 10 meter per second. This change will occur in how much time? And then finally you have to find the impulse. Are you getting the question, Alisha? Now how to solve this question? Again, very first we will write down what is given. So force is given 1000 Newton here. Mass of the vehicle is 500 kg. Its velocity is changing from 2 meter per second to 10 meter per second. Please see to the board. 2 meter per second is its initial velocity and 10 meter per second is its final velocity. Right? So first write down. F, force is 1000 Newton. Mass of the vehicle 500 kgs. It is moving with initial velocity 2 meter per second. And now its final velocity after the force applied is 10 meter per second. Now we have to find that in how much time this change will occur. Is that clear? Okay. So force is given, mass is given, right? So we can find out in the first step, we will first find out the acceleration. F is equal to m into a, right? Are you getting it, Alisha? Okay, so first we will find the acceleration, right? Force is given, mass is given. So there must be some acceleration produced, right? So we will first find out the acceleration, F upon m, right? F is 1000 Newton and m is 500 kg. So this is 2 meter per second square, right? So what is the acceleration? Acceleration is 2 meter per second square, right? Now we have to find out the time, right? In which this change have occurred from u to v, right? So as we know that the first equation of motion, by first equation of motion, what is the first equation of motion? V is equal to u plus at, right? V, you know, u is also given. A we have already found it out, and now we have to find t. Hearing that? Okay. So now put the values. V is 10 meter per second. Okay. U 2 meter per second plus acceleration 2 meter per second square into t. T we have to find, right? Okay. So t will be 10 minus 2 upon 2, right? That is 8 upon 2. So t will be 4 seconds. Getting that? Okay. So in how much time this change will occur? This change means change in the velocity from 2 meter per second to 10 meter per second. This change takes place in 4 seconds. Is that clear? Now we have to find impulse, right, in the question. Now what is impulse? Impulse is the total impact of the force. Means for how much time the force is actually applied, right? That is the impulse. Okay. So impulse is F into T, right? You can also find impulse if you know momentum. It is equal to delta P. That is P2 minus P1, right? But here we can find it by F into T, right? So using this formula, F into T, force applied here is 1000 Newton, and this force is applied for how much time? Like 4 seconds. So impulse will be 4000 Newton second, right? So what is the impulse? Impulse is 4000 Newton second. Okay. So in this way, we can find out impulse.
What's the dash?
Newton second?
Newton per second?
No, only Newton second. Newton into second.
Okay.
Okay. Force is in Newton, time is in second. So impulse is in Newton second. Is that clear? Right? So in this way, we have found out the impulse and the time. Now look at this question. Just on your video. A bullet of mass 10 gram. Mass of the bullet is given 10 gram. Is traveling horizontally with a velocity of 150 meter per second. Now this bullet strikes a stationary wooden block and comes to rest in 0.03 seconds. Getting that? Calculate the distance of penetration of the bullet into the block. Also calculate the magnitude of the force, right, exerted by the wooden block on the bullet, right? So three things here, here it is given here, right? And you have to find out force and the distance, right? The distance it is covered within the block while penetrating it, right? Okay. So first write down whatever is given. So first write down what is given. Mass of the bullet is given, M, that is 10 gram. Okay. Since it is in gram and SI unit of mass is kg, so we will first convert the gram into kgs by dividing this with 1000. So this is equal to 0.01 kg. Okay. So mass of the bullet is 0.01 kg. Now initial velocity of the bullet is already given. with which it is moving. This is the initial velocity with which bullet is fired, right? Okay. So 150 meter per second, this is the initial velocity. So write down initial velocity of bullet U. It is 150 meter per second. Now, can you tell me what is the final velocity of the bullet?
0.
It is 0 because after hitting to the wooden block, it penetrates, and after covering a certain distance, it stops, right? So final velocity of the bullet will be 0. Okay. Now, this comes to rest, and this takes how much time? 0.03 seconds. So T is also given to you. Time T, right? And how much time it comes to rest? 0.03 seconds. Getting it? Now, we have to find out the distance, right? Distance covered, okay? And the force exerted by the wooden block, right? So according to the Newton's first law of motion, Newton's first law of motion, V is equal to U plus AT, right? Okay. Now, we know V, U, and T. So we can easily find acceleration from this equation. So V is 0. Initial velocity is 150 meter per second. Acceleration we have to find, and time is 0.03 seconds, right? So this will be equal to minus 150 upon 0.03. This is your acceleration, right? So this is equal to minus 5,000 meter per second square. Minus 5,000 meter per second square. Since it is negative, this negative acceleration shows that there is a retardation, right? When it starts penetrating into the bullet, into the wooden block, its velocity decreases. That is retardation. Getting that? So negative acceleration means it is retardation. It comes to at rest after some time, right? Now, how we will find the distance covered by the bullet, right? So as you know, the equation of motion, third equation of motion, what is it? V square is equal to U square plus 2AS, right? Now in this acceleration, we have already found it out. U is known, we already know it is 0, right? So we can put the values and find the distance S, right? So V is 0, U is 150, so this will be 150 whole square plus 2 into A. A is minus 5,000 into S. S we have to find. So this is equal to 150 square upon 2 into 5,000, that is 10,000, right? And this is equal to 150 square is, yes, 150 square is 15 square is 225, right? Okay. And 10 square is 100. So 22,500, right? Upon 10,000. So this will become 2.25 meters, right? So how much distance it is covered? It has covered within the wooden block before it stops. That is 2.25 meter, right? So this is how we get the distance covered within the block by the bullet. Is that clear? Right? Now we have to find out the magnitude of the force, right, which is applied by the block on the bullet, right? Okay. Means we have to find F. Okay. So magnitude of force. applied by the bullet on the block will be F is equal to m into A, right? Okay, so mass is in kg 0.01 kg and acceleration is minus 5,000 meter per second square. This will be equal to minus 50 Newton. So force is minus 50 Newton. Minus 50 Newton shows that it is in the opposite direction. So in this way, we have found out the magnitude of the force applied by the block on the bullet, right? F is equal to m into A. Mass of the bullet is 0.01 kg and acceleration is minus 5,000 meter per second square. So this will be minus 15 Newton. Okay, is that clear? So this minus sign shows that this is in the direction opposite to the direction of the motion of the bullet, right? So bullet, if this is the wooden block and bullet is going inside this like this, then force is applied by the block on the bullet will be in this direction, in the opposite direction. So this negative sign shows that force is in the opposite direction. Is that clear to both of you? Now you can note it down.